Okay, we are starting Algebra 1, diving right in, and today's lesson is about evaluating expressions. The first thing we're going to do is define a couple of key words. The first one is variable. Okay, so when you think of the word variable, okay, what do you think of? And what the definition is a letter used to represent one or more numbers. So that is the definition of a variable. Okay, and then the next definition that we're going to write is for algebraic expression. And an algebraic expression is also called a variable expression, and that is an expression, you may have guessed it, that includes one or at least one variable. I was going to say one or more, but at least one variable. Okay, so variable is a letter that is used to represent a number. So that could be X, Y, C, P, it really doesn't matter. And then an algebraic expression is just an expression that contains at least or includes at least one variable. Okay, so what we're going to talk about first is evaluating. So in that first blank, we're going to write to evaluate an algebraic expression, we are going to substitute a number for the variable. Then we're going to perform the operations. Okay, so operation or operations, and then simplify. So to evaluate an algebraic expression, we're going to substitute a number for the variable, perform the operations, and simplify. Okay, everyone usually wants to say solve, but solve is only what you do in an equation when there's an equal sign. So not solve, but evaluate. So for number 1, we're going to do some examples down here. It says evaluate when n equals 3. Okay, so for this first one, it's 13n. So whenever you have just a number with a variable together like that, it means 13 groups of n. So if n is 3, we're going to write 13 times 3 is 39. Okay, here for letter B, it's 9 divided by n. Well, n, it's telling us is 3, so that's 9 over 3, which is 3. And then this one, it's n minus 1. So remember, n, it tells us is 3. So 3 minus 1 would be 2. Right? It doesn't say n equals 2. We just simplified and evaluated, and our answers were 39, 3, and 2. So for the next set, it says evaluate when y is 2. Okay, so this time, instead of y being, or instead of having an n, it's a y, and it's telling us that y, the value of y is 2. So what we're going to do is same kind of thing. We're going to do here 6 times 2 would be 12. 8 divided by 2 would be 4. 2 plus 4 would be 6. And then 11 minus 2 would be 9. So everywhere we saw y, we put a 2 because that's what we were evaluating for. Okay, so the next definition that we're going to fill in is a power. And a power is an expression that represents repeated multiplication of the same factor. Okay, so repeated multiplication. So 2 times 2 times 2, or 5 times 5, or 8 times 8 times 8 times 8 times 8. It's repeated multiplication of the same factor. And then a power can be written in a form using two numbers, a base and an exponent. Okay, so every time you're going to have a base and an exponent, and that's a power. And so let's go to the next page. Kind of continue up here. So the exponent represents the number of times the base is used as a factor. Okay, so let's look at this 3 to the 4th example. Okay, so the entire thing, I'm looking for a different color here. The entire thing is called a power. Okay, that whole expression is a power. 3 is the base, and 4 is the exponent. Okay, and so the power, right, is made up of a base and an exponent. The exponent tells us how many times the base is being used as a factor in repeated multiplication. Okay, that's a lot of words. All this means is not 3 times 4, but 3 being used as a factor 4 times. So 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 would be 81. Okay, so if you are like, whoa, what just happened? Okay, it looks like this. Let me do it over here. Okay, 3 times 3 is 9. 9 times 3 is 27. And then 27 times 3 is 81. So that's where I got that. It's 3 being used as a factor 4 times. Okay, so let's look down at right here. Okay, this next where it's like a little table. And so we're given the power, then we're gonna write it in words and then write what the product would be. Okay, so this in words would be 7 to the first power, right? And what does that mean? It's just 7. Okay, it's only being used as a factor 1 time. Okay, let's look at this next one. Actually, let me do this. We'll do that one. Keep it a little more easy to understand or easy to follow. Okay, so this next one would be written as 5 to the second power. Okay, and there's a special way that we can write the second power. We could also call this 5 squared. Okay, and what this means is it's 5 times 5. It's 5 being used as a power, or as a factor, excuse me, 2 times. Okay, let's look at this third one. Okay, so this one is 1/2 to the third power. Okay, the other way we could write that, there's a special word for 3, and it would be 1/2, oops, that's a C, cubed. Okay, 1/2 cubed. So what this one means is 1/2 times 1/2 times 1/2. It's 1/2 being used 3 times. Okay, and then let's look at this bottom example. So this is the letter Z to the 5th power. It's Z being used as a factor 5 times. So this means Z times Z times Z times Z times Z. Okay, and I only put that little line through it so it didn't look like a 2. So the last little row of examples, it's kind of combining the evaluate with the exponents. So it says evaluate x to the 4th when x equals 2. Okay, so let's think about what x to the 4th power means. It means x times x times x times x. And it's telling me that x is 2. So that's 2 times 2 times 2 times 2. Okay, it's not 8, it's not 2 times 4, it's 2 times itself 4 times. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 would be 16. Okay, so one more time to kind of see what I did right there. 2 times 2 is 4, and then 4 times 2 is 8, and then 8 times 2 is 16. Okay, let's look at letter B. It says n to the third when n is 1.5. Okay, so n to the third means n times n times n. And it's telling me that n is 1.5. So that's 1.5 times 1.5 times 1.5. Okay, and it really doesn't matter whether you use the little dot or the X. So I'm gonna come over here to the side, okay, and I'm gonna do 1.5 times 1.5. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. I put a 0 to show I was there. 1 times 5 is 5, and 1 times 1 is 1. So that gives me 5, 12, and 2. Okay, so that would be 1.5 times 1.5 is, and remember 2 numbers behind the decimal, 2.25. So that was these two times each other, but I still have to do times 1.5. So 2.25 times 1.5. Okay, there's not very many that are this obnoxious for y'all, but that's okay. We can handle a little bit of multiplication. So I'm gonna do 5 times 5 is 25. 5 times 2 is 10. 10 plus 2 is 12. 5 times 2 is 10. 10 plus 1 is 11. I put a 0 to show I was there. 1 times 5 is 5. 1 times 2 is 2. 1 times 2 is 2. 5, 7, 3, 3. And there should be 1, 2, 3 numbers behind the decimal. So 1, 2, 3 behind my decimal. So 2.25 times 1.5 would be 3.375. Okay, so again, you're not gonna have a bunch that look like this with all these decimals, but it's good practice, right? We're remembering how to multiply decimals, we're applying that to exponents, and we're working out our brain a little bit. Okay, and then let's just do this last one, d to the fourth when d is a third. So d to the fourth means d times d times d times d. Okay, when it's telling me d is a third, so that's 1/3 times 1/3 times 1/3 times 1/3. Okay, so let's talk about this. With fractions, when you're multiplying, you multiply all the way across the top. So 1 times 1 times 1 times 1 is 1. And then on the bottom, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And if you will remember, that's actually the example we did up here. Okay, so 1 over 81.